Example number 8. If the given expression is e to the x squared times y squared plus natural log of y plus x times y squared to the whole 4 equals to cos y. Let's do implicit differentiation, differentiate everything with respect to x because we need dy or dx. After applying the implicit differentiation, I have e to the x squared times y squared into 2x times y squared plus x squared times 2y times dy or dx plus 1 over y times dy or dx plus 4 into x times y squared to the whole cube plus x times 2y times dy or dx equals to negative sine y times dy or dx. If you look to this expression, e to the x squared times y squared equals to e to the x squared times y squared, but then you have to apply the chain rule for the inner function. This e is my outer function, x squared times y squared is my inner function. Apply the chain rule here. Since it is the product of two functions, x squared and y squared, so I'm going to apply the product rule for this inner function. After applying the product rule, I got this expression where I took the derivative of the first function, which is x squared. So derivative of x squared is 2x times, put the other function as it is, y squared, don't disturb it, plus, then put the first function as it is, don't disturb it, and then times the derivative of the second function, which is y to the 2. So derivative of y squared is 2y times dy or dx plus natural log of y. So derivative of natural log of y is 1 over y times dy or dx. Plus when you look to this term, there is a whole power 4. So I'm going to apply the power rule here first. This 4 is the outer function, so apply the power rule here first. It is like x to the 4. Suppose if this whole part is x to the 4, its power rule will be 4 into x to the cube. Therefore, I can say that x times y squared to the whole 4 equals to 4 into x times y squared to the whole cube. Just apply the power rule here and then times the derivative of the inner function. The inner function is x times y squared. Apply the product rule here because there is a product of two functions, x and y squared. Take the derivative of the first function, which is x. So derivative of x is 1 times, put the second function as it is, put y squared as it is, plus put the first function as it is and then times the derivative of the second function, which is y to the 2. So derivative of y squared is 2y, then the derivative of the inner function, which is y, times dy or dx. Derivative of cos y is negative sine y times the derivative of the inner function, which is y, it is dy or dx. Take the derivative of y with respect to x. When you apply the power rule for y squared, it will be 2y, but then don't forget the inner function. Apply the chain rule here. So derivative of this y with respect to x. As I explained to you again and again that look, in implicit differentiation, we normally say that this y has some hidden x properties. Therefore, we take it with respect to x. This is the inner function. This 2 was the outer function, so y squared was 2y and then times the inner function, which is y, dy or dx. Similarly here, natural log of y is 1 over y times the derivative of the inner function, which is y. So derivative of y with respect to x. Similarly here, y squared is 2y times the derivative of the inner function, which is dy or dx. Same thing happened here. Derivative of cos y is negative sine y and then times the derivative of the inner function, which is y. So derivative of y with respect to x. Do some algebra and simplify it further to have 2x times y squared times e to the x squared times y squared plus e to the x squared times y squared times x squared times 2y times dy or dx plus 1 over y times dy or dx plus 4y squared into x times y squared to the whole cube plus add xy into x times y squared to the whole cube times dy or dx equals to negative sine y times dy or dx. At how many places I have dy or dx? I have dy or dx here for this term, here, and then here, here. At 4 places I have dy or dx. I'm going to take dy or dx common from these 4 places. and my new expression will be in this shape. Look, when I took dy or dx common from here, I left only with this part, e to the x squared times y squared times x squared times 2y. I took dy or dx common. Similarly, when I took dy or dx common here, I left only with a 1 over y plus. Then I took dy or dx common from this term. I left only with this part, which is 8xy into x times y squared to the whole cube plus. When I took dy or dx common from here, I left only with this part, which is 8x times y into x times y squared to the whole cube. Similarly, when I took dy or dx common from here, I left only with this part, sine y plus sine y plus sine y, that is negative sine y. Because look, we shifted this from the right side to the left side, so its negative sign became positive sign. And then the rest of the thing you have to shift to the right side, like here. I have no dy or dx term here. Look, shift all the terms without dy or dx to the right side, which is this. So from positive, it will be negative on the right side. Similarly here, it will be negative from positive when you shift it to the right side. I want to get rid of this whole part. I need only dy or dx. So I'm going to divide both the sides, this side and this side, by this whole expression inside the parentheses. Therefore, I will have dy or dx equals to negative 2 into x times y squared times e to the x squared times y squared minus 4 into y squared into x times y squared to the whole cube, all over e to the x squared times y squared times x squared times 2y plus 1 over y plus 8x times y into x times y squared to the whole cube plus sine y. This is the final answer. This is going to be the derivative of the given expression by applying the implicit differentiation using method number 1.